to the cloud. Welcome to the Bucky call for the weekend of August 27, 28, depending on which side of the world that you're on. And tonight, we're going to continue with our Oblivion or Utopia discussion, where Bucky gets down to the fact that it's about you and me and what we choose. And so this is very, very exciting. Manu, how are you feeling, and what do you expect to get out of tonight?
I feel good to be here again. I see the turn up is quite impressive. 6 is a nice number. 2 times 3. What I expect is just to maybe kind of catch up with what you did. I heard it was very interesting last week. John was there with all the fire. So that's what I expect. John, how do you feel? What do you feel?
So John,
yes,
your turn. Go ahead if you like.
Oh, sorry. Yes, thank you, Manu. Just thinking about the topic, Utopia or Oblivion, and thinking of what's happening around the world at the moment, which seems to be headed in the direction we don't want to go. Yeah. So very keen to learn more about Bucky and what we can do to make sure we head in the direction we do want to go. So Joe, how do you feel, and what do you hope to take out of today?
I'm feeling very fortunate to be here, and appreciate everybody that is here. Thank you for joining us in this exploration. I keep gaining more of an appreciation for abstract thought, and I'm starting to appreciate Bucky's thoughts even more, because you can start to see things that you haven't been able to see, or you can see things holistically. So I really like this book that we're going through, Utopia and Oblivion. I think it's extremely appropriate at the moment, and I just wish Kelly were here. I wish he were, but I hope he's well. But I'm happy everybody that's here. And Julian, how do you feel? What would you like to take away from the day?
Hi Joe, thank you. Hi everyone. I'm feeling a little bit tired. It's late here in Colombia. It's been a long day. But actually I was able to get some things ready, so I was joining you at time o'clock. So I wanted to say thank you for Stephen from having to push us to get in this call like every weekend, and in that way we can keep doing this studying Bucky. So I'm hoping that I can bring some joy or something new to this study group, and let's see what Bucky has for us today. So I think we can go with Andre. Andre, how do you feel today, and what do you expect?
Thanks, Julian. I'm just privileged and humbled, honored to be part of this session. I'm just very open to accepting whatever that comes from this session. Have zero expectation, because I know it's just going to be awesome. Yeah, and yeah, that's all from me. Stefan, how do you feel, and what you want to get from this session?
Oh, wow. Just so grateful to be on the call and be with you guys. I feel a little bit gypped because you offered some really good insight, Adrian and Julian, before we started the recording. So maybe I should just go ahead and start the recording right away. So make sure that all those thoughts, those spontaneous comments are recorded for posterity, for those who want to follow up. I really like Joe's thought today about him mentioning abstract thought and how he can see more holistically. And I think that nails it. I think that most human beings, my brain is kind of geared to patterns, right? I just want to see the pattern. And if what's in front of me looks familiar, if it looks safe or enjoyable, then I hang out there. And if what's in front of me looks scary or it might eat me, then I want to run away. And this ability to think more abstractly. I mean, I've read about, I've studied ontology in college back in 1964 through 69. I went to 6 years of university and never graduated with the degree, but philosophy was one of my minors, along with political science and along with music and along with German and along with linguistics and several other things. Never graduated. But I learned the word ontology, and this call is all about it. It's all what, don't just recognize the pattern. What's behind the pattern? Is there a design? Is there a sequence? What else can be noticed? And this is like profound for me because I don't know of any place else where I can have this kind of discussion. And I'm just really grateful, really, really grateful for being here. And let's see, nobody else has joined the call, so I can't pass the buck off to anybody else. So what I need to do now is I need to quickly open up that book, which I should have had open a while ago, but I've been enjoying all the conversations with everybody. So it's quite interesting for me. So that's what I'm feeling. And today I expect we're going to cover some new ground. And I'm just really looking forward to that. My book is opening now. And so we are studying, I know for a fact, we're studying the 14 dominant principles that Bucky thinks are essential for us. And today we're on number 6 of those principles. We're going to be talking about general systems theory, which boggles my mind because he just talked about children and that was way system theory oriented. So that's quite amazing for me. Okay, here we go. All righty, good. And so here's where we're starting tonight. John Butler, if you are game for it.
Yes, I'm happy.
Right, sir. Thank you for your participation and contributions. Go right ahead.
Concept 6, general systems theory, mind versus brain. Generalizations as constituting the thinking of mind versus the information storage and feedback functioning of the brain. Topology of systems, the topological hierarchy of systems, triangulated topological quantum coordination of generalized systems, open and closed systems.
Yeah.
Wow, okay.
If I may just say that for me, one of the big epiphanies for me in reading about Bucky and what Kelly shared over the years is this very concept of mind versus brain. I always thought about mind versus brain. A lot of people use those words interchangeably, but I've come to see them very different. That brain is basically a biological phenomenon, and that somehow mind coordinates with that brain. And to have him put down mind versus brain is absolutely significant. I teach extreme mindfulness. And one of the things I teach is how willing the brain is to label every dadgum thing and to put it in a box and to either eat it or be eaten by it, right? Brain is very automatic based on the past. And mind gives me an opportunity to be forward thinking, to look at the design, to look at the consequences, to take a look at generalizations, So there's a lot packed into those first sentences, and they're kind of in italics. So hopefully that's kind of a preview of what's going to happen later on. But mind versus brain really knocks me mind against brain. Anybody else have any comments? Go ahead.
Yeah, my comment is that his generalization here is the duality of it. The stylizing into duality, because we always, in our language, confuse mind and brain. When somebody thinks well, they say he has good brains, So by putting it in a model that is a principle, that is in itself a generalization.
Yeah. generalizations as constituting the thinking mind versus the information storage and feedback function of the brain.
Yes.
Yeah. Any other comments or questions? Okay.
It allows
Oh.
clarity, really, forward.
Yes.
I do have a question regarding triangulated topological quantum coordination. I don't get that.
Triangulated
Yeah, Julian.
topological quantum coordination of generalized systems. You got a comment on that, Manu?
Okay, yes. Let's just put it this way. If you have a general set, how do you understand the set? Whatever. You triangulate, you have 3 points. The minimum pattern is a triangle, right? So you triangulate always in order to divide and understand. And you do the integration by adding triangles, adding them to put them together to have the view of a whole.
The Bible says, by the mouth of two witnesses shall you know the truth. There's a triangle right there.
Hmm.
It's like it is the complete structure. And when we start playing with these magnets over here, whoop, dadgummit, they don't like to be moved around. When we start playing with these magnets, we come to the, we realize how that any structure other than a triangle, it will just flip-flop. Before I came to these calls, I used to think that, you know, the square was the cool deal, but the square collapses. I mean, it's just not stable. It's all wiggly, right? But as soon as I make it into a triangle, that structure is now, you can't crush that triangle. If I had balls on there, I don't have balls. I got balls somewhere. I didn't bring my balls. I got balls over here. But that triangle can't be crushed. And so like the Bible says, you know, out of the mouths of two witnesses, and there's your triangle. That's your basic structure. So I always think in threes now. Usually that's usually 1 versus 2, 1 or 2. I always choose A, B, or C. I have to have a C in there. You know? And okay, any other comments or questions about triangles or anything else?
If you've got one, you can easily delude yourself. I mean, you can't get another point of view if it's just you. If it's two people only, you can have opposing points of view, but not necessarily an independent point of view. The moment you have a third person, you're each better able to exchange ideas and see a different point of view. I think it's also the Jewish faith says that you should not study the Bible alone. That because you read it, you see it only from your point of view, you don't necessarily get any understanding or a different perception or point of view. And yeah, we understand because of Bucky the importance of the triangle and particularly the triangular prism.
Right on.
So are we saying that with the mind and the brain, understanding that on your own is extremely difficult, if not impossible? But the moment you have the third point of view, you're better able to see and understand what's happening. So the triangulated topological quantum coordination of generalized systems, I'd still appreciate some greater clarity around that too. So generalized systems we've been studying, we're talking about the topological quantum coordination of generalized systems.
Good.
I think it's how things are interrelated. I mean, essentially within a system. Essentially, that's what topological thinking of structures are. I'm trying to think of an example that would be good. I mean, we're talking about how different points as far as a triangle are interrelated. But thinking about it in generalized systems theory, I'm trying to think back earlier into the book, even when he was using the example of air travel and how systems are interrelated with one another.
Do you remember the cosmic
Yes, cosmic hierarchy.
yes.
Yes.
All right.
Yes.
So you have it is systems, isn't it?
Yes.
Okay. Now, how do you go to the finest? What is the minimum system?
Well, you were saying a triangle just a moment ago, but
Yes, the
isn't it? It's a
minimum,
dual,
the
but a
minimum
minimum of
stable,
two.
stable system.
Okay, the triangle is the minimum stable structure.
Structure, it's not a system. So it's a duality that we're talking.
So where does the system come in? All right,
the
so
diagram.
here's your
Minimum
triangle.
of two. It's a minimum.
There's your
A
structure.
system is a minimum of two, isn't it?
Well,
No, all I think all are system.
yeah. There's
All
your
are
triangle.
system.
You can't compress it. Now bring in one more vertex. And then somehow now by adding one more ball or one more vertex, I go from 3 vertexes and 3 edges to 4 vertexes and 6 edges. And now I have a stable structure. One more
Okay.
vertex, add 3 more edges.
Okay.
I think you have system before structure.
Really? Yeah, because I guess this is a system.
Yeah.
One of these is a system.
Yeah, and cosmic integrity is a system. It is a system.
Yeah. Well, it's many
nature
systems.
is a system.
Yeah. Actually, it's many systems.
Yes.
It's cosmic integrity, it's synergy, it's nature, it's unknown, and it's known. It's metaphysical and physical. These are all systems, I suppose, a cosmic hierarchy of comprehensively embracing and permeating. They embrace each other and they permeate each other. Generalizations of generalization. There's our cosmic hierarchy.
Yeah. And notice that it is topological hierarchy.
Right.
Yeah. I want to comment on topological hierarchy, if I may, you guys, because I think
Please.
this is critical. Here we go. The we all know what a topographical map is, right?
Right. Right.
We take a topographical map, and we could do a Google map right now of any place in the world, and that would be fun. And Joe, if you want to grab a topographical map of Cape Town or whatever, you'll see there are little circles going around, each indicating an elevation of a thing. A topographical map tells you where the peaks are and the valleys are. That's what a topographical map does. What is topology? Topology tells you what a mountain is and what a valley is.
Yes.
That's an abstraction. Because now I know what mountain is in topology. And then once I know what a mountain is, now I can put it on a topography and I can say there's a mountain here and there's a valley there. But unless I have a topological definition of mountain and valley, I don't got anything. So when Bucky starts talking about a topological generalization, I think that's exactly what these cosmic hierarchies are. These are topological. In other words, cosmic integrity, yeah, you can't put that on a map.
Yes.
But without it, there is no map. You know, synergy, you can't put that on a map, but without synergy, there is no map. I'm stretching a little bit here, and I want to make that point. Comments, questions?
Yeah.
No, that's a good example.
Yeah. And it goes to the level where we know something that is universe. If we know, the only way we know is by structuring.
Yeah. And we
the only way we know is by structuring, is by reducing to the minimum and see how we put these minimums together back to make sense of a more general. That's the only way we know. That's why we go by experience. So we're accumulating small things, and then we see patterns. So you see now, structure has to do with us, with induction, basically, with us knowing, with us expanding into knowing further and further how it is.
So I want to come back to the point, that little guy right there is a system.
Mm.
And how do I know it's a system? Because it has a topology. And now when I put it into the context and I start bringing things together, now I begin structures, but this is free floating. And then I start then I start triangulating. And as soon as I start triangulating, I start solidifying. And while that thing can spin this way and this way, there's no way to collapse this puppy.
Yeah.
This is absolutely the minimum structure.
No, that is the minimum form.
A minimum form.
Yes.
Exactly right. The minimum structure, I have to bring more to play.
Yes. You have to be able to enclose the volume.
And
Make it-
so,
Triangular prism.
Yeah.
and the way I enclose the volume is I bring in one more vertex, one more vertex system. And as soon as I do that, I now have 6 edges
Yes.
and I have a minimum structure.
Yeah.
So
And notice that the duality, the topology of duality had to come to play and interact for you to have a structure.
And notice that
You brought it one convex, one concave triangle or whatever, one closed triangle and another one that was convex. You put them together to put to make the tetrahedron.
and I'm really quite grateful for these magnets because this two-ness we talk about all the time. Let me find another purple guy here. Or no, need another yellow guy.
Steve,
Yeah.
show
So,
again. Steve,
Yes.
show again your triangle, the yellow and the white. No, show them separately.
Okay.
Please.
Well, I actually changed the structure. Let me just bring this to bear. You see this one right here? And then I'll bring up the other one later. I'll bring up back the other one. You see this purple guy here? Here's a two-ness right there. You see this purple guy right here? There's a two-ness. I have a two-ness and a two-ness connected by 6 edges. But there's my 2 and there's my 2. And they are, by the way, orthogonal to each other, which boggles my brain. Those 2 purple stems, edges, are orthogonal. They're at right angles to each other. This was a big mind blower for me when I came to this two-ness right there. And now
But
put this down.
There's more, Steve.
Go ahead.
Let me just show it now.
Okay. I'm going to stop
know.
showing the screen because
Yeah, it's going to clarify a lot of things. You see, topologically, this, and this are the same thing. I just need to put do you get me? This, and this are the same thing, topologically. You see that?
yes.
It's the same thing, the triangle, by definition, right? I can get any of those by doing small changes that doesn't do anything. It's a triangle. You have a continuous change. It's like a cone, the conic forms. You have a continuous change, continuous. There's no disruption to get in there. It's an abstraction, isn't it?
Yes.
Okay. So if I bring two of these now, like that and that, I make a tetrahedron.
Mm.
Comments, questions?
And a tetrahedron would be considered a closed system.
Yes.
Is a closed.
That's right.
This closed.
Right.
But in terms of system, we saw that this was also a tetrahedron. It's just that it is convex.
Mm.
We've been seeing this all the time. Right?
You
It's not
mentioned
concave. This is concave. It's closed. Question?
Yeah, I have one. You mentioned continuous, like when you have the three pieces apart from each other and then you join them. There's got to be a continuous change in order to happen that.
Mhm.
Does that mean that when in a system there's no continuous change, but you see something here and then you see something different in another moment, that is not a system, or maybe we're looking into two different systems, or what is this continuous means then? Like how is that?
That is one of the characteristics of a topology. One of the characteristics of a topology is that is with regard to any variable, the change that you make is not big enough is small, it's a small change. Let me put it this way. If you have a function that you define as the topology and the variable x, if you change x in a small way, the change in the function also, the resultant change is also a small way. Otherwise, there is the disruption. So when C we're talking about the mountain, if with a change that is horizontal, you have a fault, it's no more a mountain, it's a truncated mountain. You get me? If it does this. A mountain has to do this. A valley has to do this. Does it make sense to you? If in the course of doing this, the valley did this and then that, right? Or that, I don't know, in a way that is abrupt, that is cutting, is not the same topology, it's change.
Okay, yeah, and I like the way you call that, like a disruption.
Yes. If you are at sea, if you are at sea, whatever change, you're still in water, isn't it? Even when there are turbulences, there's water. You don't have change, water, air, and water. Do you have that at sea?
Yeah, I agree on that.
You know, a fish does not swim into something that is water here and air. If a fish goes from water to air, it gasps, is going to die. Right?
I see.
Yeah. So
I
it
see.
is that. Yes, Steve, go
I
ahead.
often wonder what a fish is thinking when they jump out of the water and go into the air. Have you ever thought about that? What is that fish thinking? Like whales and dolphins do it constantly. That's how they play, right? It's like they live in their dimension and they come out of their dimension and go back in. But like trout will jump. What the hell are they doing? What are they experiencing?
No, the change. Look at this. When they jump in the air, the change in their living system is not big enough for them to die.
That's right. because they're in and they're out.
Yes.
Yeah.
Yes.
Okay.
Thank you for that.
So I was just going to ask basically, how does what we're discussing here relate to the map? How the map is not the territory, essentially. So how the models are models of the world.
Have you guys
Dalton-
heard that saying? Historically, it's kind of a cliche slogan, is the map is not the territory. Have you guys heard that?
Explain further, Steve.
Yeah. Joe, explain that. I'm gonna look it
So
up.
it's how our models of reality don't match reality. So that what we think about the world, what we think is a mountain actually, or how the mountain is structured conceptually, doesn't actually match what the mountain is. So I'm thinking about how this relates to that exactly. And this is, you know, this is also used in natural language processing and everything too. How concepts and reality don't match to one another. And I'm
Well,
thinking
that has to do with the way we see. We see with structures, we said it. And structures are simplifications.
okay.
So I just put in a little definition. What Joe brought up was from a philosopher engineer, Alfred Korzybski. And he used to say that people confuse models from reality. The model is not reality. It's only a model, and they're making these big decisions based on their models. Models stand to represent things, but they do not they're not identical to those things.
And it can dangerously mislead you, because if you have a model that is only one phase of something, that's the reality, you stay in the phase blindly until the black swan comes and crushes you.
Yeah. It's like I understand topology, so I assign values to different shapes and I create a topography.
Right.
But the topography
doesn't match the topology.
that does not necessarily match the topology.
And that's
And it
where
depends on how I calibrate, right?
right.
Because the smaller the increment of calibration, the more accurate the model is to the reality, but it still is not reality. And the temptation is for the brain to say, oh, I get this. This is a pattern. I got it.
Brain and mind.
Yeah, this is brain versus mind. Brain is topography. Mind is topology. Maybe.
That's the way I'm looking at it.
Yeah.
That's biological versus the mind, which is more conceptual.
And if I'm not careful, my brain will tell my mind what my reality is.
That's why beliefs are so important.
That's why it is important to always question all the time.
Right.
What is another definition of question? To me, another definition is turning your structure. Turn it to see something different.
It's like I'm in my meditation and up comes a sensation, and my sensation is attached to a label, and I release the label to see what's underneath the sensation. I'm constantly examining the topology of my experience rather than examining the labels of my experience.
I was in a conference today, not to divert it too far, but I was actually going to bring this up in my opening because it was about Socrates, right? This basically how to question everything about your own reality. But it comes back to exactly what we're talking about here. We're calibrating. We're continuously calibrating.
Yeah.
So it's the same thing that Socrates would do in ancient Greece.
So when I'm meditating and a sensation solidifies into a thought, that thought is based on a calibration that my brain is used to. So I recognize that as a potential trick and I release that label immediately and invite my brain to recalibrate.
Right.
Because maybe the thought I'm having, I'm only having that thought because there's a part of my brain that does not want to experience a certain emotion. So rather than getting pissed off, my brain goes, oh, that's just like my dad. because my dad pisses me off. But by converting that emotion into a thought, now I'm stuck in a rut. Oh, that's just like my dad. And so I really don't know what the actual sensation was. I only know what the label was.
Hmm.
I want to release the label. Look at the topology, brand new, recalibrate. Whew. Boy, is that abstract thinking.
It's abstract, but it comes into the concrete very quickly.
Does it? How so, Joe?
I mean, just thinking about how what we were just talking about with brain and mind, or how you're demonstrating with the magnets about how these things work together. No, so it becomes this abstract ideas that we're coming up with manifest themselves in reality, and you guys are able to demonstrate that. That's why these videos are so important.
Wouldn't it be cool if I can walk down the street and somebody would hold this up in front of me and say, oh yeah, that's a great tetrahedron.
Exactly.
But I wouldn't think that, would I? I'd say, what is that?
But
Some kind of weird
most
kite?
people don't think that. Unfortunately, that's the problem.
Yeah. Anyway,
No, it's
what a fun conversation.
it really is fun. It really maps into what I was into the conference on Socrates that I was attending a little earlier today.
And did you notice you just used the word map? That maps into the conversation.
Exactly. Yeah.
that cool?
Yeah. Exactly. Yeah.
Really, I mean, that's how the brain works. Is it maps, it takes something, recognizes a pattern, and it fits it into another pattern. So my brain is mapping out my reality. Whoa, this is so powerful. Okay. Any other comments or questions before we read on? Okay.
Yeah, if you can get back to the phrase, I have a back knowledge about quantic and all of that. What I can remember is that in quantics, it was when an observer changed like what was happening. So I'm thinking here if Bucky is mentioning here topological quantum, like, or topological or quantum that is triangulated, it makes me think of one of those vertex, like is an observer, and two other things that are being observed, and only by the action of observing it they can change. So there might be also systems where we can have that relationship in the quantic world. Like, is that what maybe Bucky is inviting us to think, like, not only in these systems that we can touch and see, but also other kinds of systems that are out there and we don't really understand how they work, but they are connected. They have somehow a triangular relationship.
Perfect observation, Julian.
I think what is being said here, without answering directly what you say, William, is this one. When I trying to understand what coordination means. Coordination means knowing the way, knowing how to situate in a context, or again, putting into context, right? So when you say coordination is to play on many things to get to a point, to be able to get to a point from a reference. That's why you say coordinate in a system. So the intellect, what it does, it coordinates quanta, parts of that whole that we can conceptualize into making a sense pattern-wise. That's why you identify, for example, patterns of triangles. Like if you take a piece of linen that has been dyed in different colors, like your pullover that you have now. I can see blue and red, right? I can see the pattern, but that was coordinated. I can say you have stripes of red and stripe of blacks alternating. I can even further say that around your neck, it is circles that are alternating. Does it make sense to you? There is something that is whole, and how do we understand it? We take parts, but we're able to coordinate how they are put together to make a sense, albeit local. I'm saying relatively local. Because our process is generalized by further and further inductions.
Further and further inductions is what you call them?
Yes, we are inducting. We don't know everything, but we are pushing boundaries by more and more generalizationism, by coordinating further and further from where we are.
Yeah, like so if we are doing constantly these generalizations, for example, when we study the universe, like when you study I forgot the name, there's things in the space that you don't see right now, like things that might be hidden because there's no light, so we cannot get to that. It's the same thing, like there's going to be things in other fields rather than astrology that we're doing the same thing, like there's things that we're not seeing. Is that what you mean with inducting? Like
no, what I mean is that there are things that are. The cosmos is, right? They are. By thinking, I'm understanding that cosmos. I'm trying to understand that cosmos that is. And the thinking process, one of the tools of thinking process is induction.
Okay.
That is generalizing from less to more, right? And that is the process of veritas. That's all I'm saying. There are things that are, there are general principles that are there. But I, this little guy here, or we in this, we want to understand it. How do we understand it? We understand it by the process of thinking. And Bucky is describing what thinking is.
I see. That's helpful.
Yeah.
Okay, and I put
That's
those
helpful. Thank
I
you.
put those experiments about the observer. There's a couple of really good explanations of the split screen electron experiment and the quantum erasure experiment, which actually they took they took a photon, split it, so it was twins, and they delayed one, and then they had reactions occur, and every time the delayed reaction was the same as the observed reaction, even though it occurred after or before. Didn't matter if it occurred after or before. If it was observed, it was the same. This is called the quantum erasure rewrites the past experiment.
That is time abstraction. Time is no more.
Right.
Anything there.
Observation seems to be a key.
Mm-hmm.
Yeah, very interesting.
Thank you, Steve. Those should be really entertaining. I'll take
Hey,
a look.
listen, I pondered those for decades. Those are really good ones. So thank you for being excited about it. Okay, my gosh. Are we ready to leave the first paragraph? Triangulated topological quantum coordination. Open and closed systems.
Okay,
So all right, let's go from there. Are we ready, guys?
Yes. Yep. Comprehensivity, theory of general systems. As with the preceding items, we again find each and all items to induce considerations of their integrated comprehensivity. We find all the non-simultaneous events of universe tending to affect all other events in degrees ranging from powerful to insignificant.
Okay, let's pause right there, you guys. What do we find all the non-simultaneous events of the universe? What is he referring to right there?
Our experience?
Yeah, he's
I missed
referring to each individual human being's experience.
Yeah.
That you're having an experience of the universe. 6 of us here on this call are having an experience of the universe, and it's non-simultaneous.
Right.
You're seeing the universe from where you're sitting, and I'm seeing the universe from where I'm sitting. We see 6 different universes. It's non-simultaneous. And the only way we know the truth is by collaborating together and trusting each other.
Mm.
Non-simultaneous events of universe. And all of these events tend to affect all other events, from powerfully to insignificantly.
What's the difference between concurrent and non-simultaneous? So the 6 of us are sharing this experience concurrently, but we're saying it's a non-simultaneous event?
Yeah.
No, we're not saying that it's a non-simultaneous event.
I am. I'm going to be
Right.
bold. So Manu, go ahead. You make your point.
No, make yours. I'm just
Okay.
quizzitive.
Yeah, he uses this all the time when he's referring to human consciousness and the nature of universe and what is universe. It's about a bunch of non-simultaneous events. And then you mentioned some of them could be occurring concurrently, like we're doing here right now. But don't you agree with me that even though we're concurrent, that each one of us are having our own experience, and
Yeah,
that
sure.
that you could get something out of this that I might be missing, and if you don't share with me, I lose. Right? If you don't share with me, then your experience is completely insignificant. It's not insignificant because it was insignificant. It's insignificant because you didn't share it.
Insignificant to you,
And-
Steve.
Exactly
No,
right.
but
Exactly right, John.
he's talking about simultaneity of our experience now, of our experiences.
Yeah, like right now, like
Yes.
everything.
It is simultaneous, but the intensities are different. That's what makes it
Exactly.
different, in my opinion.
So we're here, but
Mhm.
we're having conversations that like each one of us is taking our turns and speaking, which makes our experience actually different, right? So
Yes.
that's non-simultaneous in its explanation. So
So it depends on what you take. If I take Steve's experience, yes, and mine, just by the fact that we intervene differently, we listen while the other is talking, or we fight, we do things, that is a different call. But the call as, this call, is it not simultaneous? I don't know.
no, it isn't, but here's that he qualifies it by powerful and insignificant,
Yeah.
right? So there are degrees so I'm trying to gather my thoughts around what that means exactly. Like, so it is that we are coordinating here. I mean, so there is this level of coordination,
There's a level of concurrency.
level of concurrency, but it's insignificant. It's significant to
be.
us. It's significant
Can
to
you
us.
put again the text, Steve, please?
Okay, I was just doing some other searches for non-simultaneous, and on page 16, here's one. Metaphysics and physics are thus seen to confusion, to conserve progressively the self-generation of non-simultaneously and overlapping evolving universe. Man's
Yes.
function in universe is metaphysical and anti-entropic. So this is where he refers to human consciousness as being part of this non-simultaneous experience of universe.
Mm-hmm.
We can do a random, another finding for this non-simultaneous, and we'll see what the next one is. Here's another one. The a priori and only intellectually conceivable complex of self-regenerative, intertransformative macro, cosmic ranging scale of generalized principles governing non-simultaneous universe. Thus far discovered by man only in piecemeal isolations. So he's kind of referring to individual experience here, don't you agree? Or
Yes.
it just could be my prejudice. So don't believe anything I'm
No,
saying.
I'm pondering again at the question of man function in universe is metaphysical and anti-entropic.
Mm,
Yeah,
Can I suggest what I understand here? So man function in the universe is to understand the physical
mhm.
and to use that understanding to build things that are anti-entropic, because entropy is a general principle. Anti-entropic is a generalized principle. You get what I'm trying to say? Entropy is what it is. God is God. My temple of God is anti-entropic. My temple that I build, the temple that people build to worship God, is a temple that is meant to focus their thought for the time of their experience to the general principle God.
It's to bring order to chaos,
Yes.
essentially.
So anti-entropic to me is generalized. So our function is to understand and then to apply. Understand, apply, understand, apply. If you apply without understanding, it is something else. If you try to understand without applying, it is also something else. But it's not what seems to be our function. Our function seems to be bring those two together. Understanding and applying.
cool. We ready to continue?
Mhm.
I thought, Manu, that this about understanding and applying was only to learn something new, but you just expanded the definition for me of that. Like understanding and applying is more than only in educational context. Thank you.
No, it's not
yeah.
me. It's thousands of years before me that people realize that, that what is our function. Steve, can you repeat? We discussed that on Wednesday.
Mhm.
About what?
Application and
Oh yeah, you brought up that
understanding.
quote.
Yeah.
That was it. Yeah, here it is. It was oh look, Susan's joining us. How wonderful is that?
Oh, nice.
It's knowledge and practice. And this is something that Manu brought up, and then I went and found it. Oh, this was a statement from Confucius.
Between surgeries. Between. Hi, Susan.
Hi. I'm catching Confucius. That's awesome.
Yes.
Here we go. The essence. Oh, I don't think that's it. My gosh.
Oh, I remember what you. Hang on.
Yeah, shoot. Did I put it in the?
You did put it in the chat.
I put it in the chat. Let's see if we can find it here. No. Dadgummit. Confucius. Knowledge without practice is Meaningless.
Meaningless.
I think that was it.
Meaningless.
Yes, there it is. Knowledge without practice is useless. Practice without knowledge is dangerous. I'll put that in the comments. Then I think we're about to read here.
Yes.
Isn't it?
So we were down to powerful / to insignificant, right?
Were we? Oh, yes, we
Yes,
were.
we were.
Yeah. So we're about to begin our third paragraph for the day.
Yeah, yeah.
This is a long paragraph, so
This
you
could take
bragging?
the rest of the day.
Are you
so
bragging?
we only might have 3 sentences here.
My own generalizations from the total of my own special case experiences, as well as from other scientists and mathematicians, especially my experience on the sea and in the air. What did you do to me there? Brought
Sorry.
me to a clear-cut discovery of 12 fundamental degrees of freedom governing the external and internal motions and transformations of all independent systems in universe. I think I'll do the next 2 sentences. 6 of these freedoms are positive and 6 are negative. Therefore, there are only 6 sets of fundamental freedoms. These cover all variable interrelationships of universe. Okay.
That's a good place to stop, I think.
Yep.
Wow. So he's talking about the 6 degrees of freedom,
Mhm.
Mhm.
concave and convex, right?
Yep. That's it.
You remember what he said before? He talked about how the influences of things on things are either acute or weak, right? You remember that? Powerful to insignificant. It's just there on top. We
Mhm.
find that all non-simultaneous events of universe. Steve, can you,
Close your search box.
yeah,
Have I got a search box open?
Yeah, you
Yep.
do.
yes.
Do I really? I don't see it.
See the find.
Hang on.
Come
I've
down.
got-
Non,
oh,
where
I'm
you have the
sorry.
non-
non.
Thank you very much. I'm sorry. It was behind my dashboard.
Okay,
panel.
so what I was going to say is that if you read that, we find that all simultaneous events of universe tending to affect all other events in degrees ranging from powerful to insignificant.
Mhm.
Okay, so what he's talking about here, you have systems, and systems are made of relationship between things. And how are these things are moving? How do they move in relation to other? Right? That's what you call the degrees of freedom. In what way do they move independently from another way of moving? Andre, does it make sense to you?
Well, to be honest, this week has been very deep for me. hence I'm just trying to digest every single. It's just amazing. It's just amazing how you guys dissect a couple of sentences and go 6 feet deep, and then go 6 feet the other way around. And I'm still trying to figure out the things. So my apologies if I don't contribute a lot, but I'm listening.
Can I help you,
All right.
Andre? Can I help you? I think I can help you. Because,
Yes.
okay, there are things out there. We talk about system, it's systems of things, isn't it? I don't define what the thing is. It's a system. So those systems are out there. They are structure and they influence each other. We saw that, right? Okay, they are influencing each other in a way that is from very powerful. Say, for example, I'm very close. If I'm very close to you and you hit me in the face, that is really powerful to me because I really feel your kick on my face, right? Okay, so it's from very powerful to insignificant. Now, what we're talking about, degrees of freedom, is in how many ways can you move? Let's just put it, I'm not saying that is a degree really, but just something for you to understand. If you come to a crossing of two roads, right? There is a stop. You can stop and you look. You can either go straight, you can go right, or you can go left, isn't it? Or you can U-turn. Do you understand that, Andre? You drive in your car, you come to a stop. And the stop is at the crossing of two roads. You can decide to go straight, to go straight, you can turn left, and you can turn right. Do you understand to me? Do you agree with me that those three ways are independent? Yeah. Because they will never, if you turn right, it's not going to take you in the next to the destination when you turn left. That is to make you feel about what a degree of freedom is. But the system is still, you still have your car and there's still the roads. That is the system. So those are, you are moving in regard, in your car, you are moving in regard to the roads. These roads are still the road, your car is still the car. But in relationship to that road, to those roads, you are moving in a certain way. These are degrees of freedom. Freedom means, I would say, I would just feel, this is again feeling, expanded. Does it, do you feel it? I'm not saying you understand it, but do you have a sense of it? A practical sense of it?
Would you guys like to see another application of 6 degrees of freedom?
Mm-hmm.
All righty.
Yes.
Here we go. Have you guys heard of bird murmuration?
Oh, yeah.
This is this.
Okay, yes, that will help too.
I pondered this for many moons. And I was looking for the little thing, but the way murmuration works, these birds make all these great things in the sky. There are 6 degrees of freedom. There's a bird up here, bird down there, bird over here, bird back here, and bird up here. And that energy can go both directions. When this guy watches this guy, if he starts to move, this guy moves, this guy moves, this guy moves. If this guy's watching this guy and this guy moves, then this guy and this guy and that guy and that guy moves, and they create these great formations in the sky. This, by the way, is an octahedron.
Could you explain the seventh move there? Because I think that that's really important for a number of reasons. I'm just thinking out loud.
That's seventh direction.
That's seventh direction, right?
Is the direction inside. This is this.
It can only be inside.
Yeah.
Because I'm just thinking about this, how it relates to 7 bridges of Königsberg. But anyway, that's something different.
Oh yeah.
That is the referential, Joe.
Yeah, okay.
That is the point of referential, the bird in the center.
Yeah.
So information is going out and coming back in. Going out in 6 directions and coming back in to that guy. And that's the way the whole system moves.
And the 7th direction by Native Americans is considered the sacred direction because it's the direction within each of these individuals. It's the center of the universe. When one enters a sweat lodge, one enters the center of the universe. Einstein said it. Every time and space are relative to each individual, the observer. And the Kabbalah said it. That's what this octahedron represents. The Native American 7 directions are representing the same thing. And Bucky talked about it in terms of 6 degrees of freedom. And what boggles my mind, if we're ready, let's read the next paragraph because Joe
Next
works with
sentence.
the next sentence. Yeah. Joe works with the Navy.
It's actually
yeah.
12, isn't it?
Yeah, it's actually 12.
Yes.
Right.
But the other 12,
Right.
the other 12 is metaphysical.
Mm-hmm.
You
Well,
understand?
wait, no, actually, because I
The
thought it was
other
positive
6
and negative.
metaphysical, yes, is negative.
Right. So we can call negative metaphysical. And
Okay. All right. That's
physical.
fine.
It's all
So
a
that
metaphor.
is the center of Steve. Actual fact, that what you call 7 is actually a condense of 6 coming back information.
Right on. Right?
You
The
know what I'm
7
trying to
is
say?
all 6 coming back in. That's the
Yes.
7. There's all 6 coming back in.
In order for anything to change from physical to metaphysical or vice versa, it always passes through the 0 point. That's why you say 0 plus and 0 negative.
And by the way, this relates to non-simultaneous universe because here are these 7 birds, right? And this is non-simultaneous. They are concurrent, but they're all reacting. They don't move exactly the same way every time.
Right.
One moves and the others follow.
Yeah.
So it's
But to have
non-simultaneous. Go ahead.
Joe, to have Andre especially here, you have, let's just say you have geography, or you have a system, and then you have how part of systems move between them. Degree of freedom has to do with how we move in relationship in a system to another. It is quite important, otherwise it's going to be confusing when we talk about dimension and degree of freedom in the future. You hear me what I'm saying, Andre?
Yep.
We are here. Let's just say we were in a set here. We are in a conference, or we are in a meeting within a company, and Steve is the boss, and there are rules. We are 6 here or 7, all participating in a meeting. That meeting is a set. But within that meeting, there is an order of talking. I cannot just interrupt Steve when he's talking, right? So Steve has more freedom in the meeting than me. Or in some context, for example, it can just be that I participate, I'm muted, I cannot speak when you want to convey a message. So my degree of freedom as a participant is less than the degree of freedom of a speaker or the speaker of a meeting. That's what I mean. Does it make sense to you? We are all still, yes, we all still elements of a meeting. We all still part of a meeting. But some people have more freedom of speech than others in that meeting. Put it into that context and it will help you to understand this.
Well, when you guys explain in within the couple of sentences, a lot of it makes sense. However, looking at different paragraph to different paragraph and linking to it, that's the part right now. The word that comes to my mind is perspective, because even within that 6 degrees of freedom and non-simultaneous events and all this, it's a matter of perspective, where different angles people are looking at different things, and people are gauging the definition of the event based on what their angles is. So that's where I'm looking at how this concept 6 general system theory is working within within my
Okay,
understanding of the paragraph.
let me jump forward for you to understand, Andre.
Yeah.
Bucky goes further to describe the 6 degrees of freedom. He say anything can spin. You understand the spinning?
Mhm.
Okay, spinning is different from orbiting, going around something, right? It's different.
Mhm.
So the spin is 1 degree of freedom, is one way you can move within the system. Andre, you can decide to spin. You can also orbit around, say, you can say you're orbiting around Steve. In the play of kids, they do that, especially girls. They do games when one girl or a group of girls are orbiting. They're going around a central girl, right? That is orbiting. Now, the third one, if I do this, look at this. This is the case of my glass. If I do this, so this hand is going that way, that one is going this way. It's called torsion, right? Torque. You understand what I'm trying to say? Torque. That's another way of moving. Then there's another way that Becky called poking. Poking is when if you are kissing somebody, right? Your lips and those of that person are sucking each other, poking. That's poking. That's the way of moving. And there is the one that is called inside out. If you take something, you press it in, it goes inside, or it can also go out, it can radiate. So it can compress, gravity, it can radiate. That's another way of moving. And the last one, which is the most difficult, is what we call precession. Just look at the moon and the earth. The moon is always orbiting around the earth, right? Always. Since you were born and you came to consciousness of that, you've been told it's never fail you. It's always. But what prevents it from being swallowed by the earth, from falling on the earth, is something that's called precession. That is body in motion and influencing other bodies in motion in patterns that are different other than 180 degrees. You get what I'm trying to say? So those are the 6 things that he discovered. And it's not a perspective, there are things that are there, it's reality. So he understood that there are 6 degrees of freedom. And he didn't stop at the abstraction. He went further to describe physically. Now it's physically for us to see, for us to feel, for us to experiment, for us to replicate what they are. Does it make sense? So that cut out perspective in the understanding of the system and understanding the dynamic of part within the system.
There are some really good murmuration videos here. I'm going to drop this link into the chat. So if you want to watch some murmuration videos, they're there. And I think we ought to continue reading. I think these next sentences are going to just reinforce everything that we've been talking about.
Okay.
So I think we finished with these cover all variable interrelationships of universe, didn't we?
I think so.
Yeah, okay. You want me to start reading again?
Yeah, right there.
They become the controlling facts governing general systems and thereby such super complex systems as the design of a nation's navy. General systems design science includes the Navy's progressive fabrications and evolutionary replacement, manning, operation, establishment of naval bases, repair, maintenance, evolutionary modification, support, logistics, ballistics, and industrial tools to make tools. All these functionings are comprehensively and anticipatorily undertaken under a system of time controls and priorities, which in turn are governed by fundamental resource programs and the political mandate for its existence.
Wow.
Wow.
This
So
kind of
saying the
refers
Navy's
Well,
an example of complexity.
It's, it,
Joe's a civilian contractor for the Navy, by the way, everybody.
well, the interesting thing is the maintenance issue is one of the biggest problems that the Navy currently faces. And one of the reasons they face that problem, as I was having a conversation with somebody, I don't know, months ago, was the experience factor. The experience factor of how one ship, what its experience is versus another ship's experience. Therefore, not taking that into account would be, kind of would make it difficult to predict when something needs to be maintenance and when something else. It's not all just needs to be maintenance at the same time. So if you have a ship that's out to sea, let's just say on the, in I don't know, in the South China Sea, and then you have a ship that's in port doing nothing. Those are two different experiences. But they didn't necessarily distinguish a lot of times between those two experiences. Maybe I'm exaggerating a little bit between import and, but let's just say they were both, one was in the Persian Gulf and one was in, South China Sea. But one of the things is that they would treat everything the same. They didn't treat them as different experiences. So they treated them as simultaneous experiences, not non-simultaneous experiences. So so some of these ideas of the predictions, the maintenance, the logistics and all that, it gets kind of messed up when you're working with that. So it's important to account for that anyway.
I think for me, two very, very strong keywords. Comprehensively.
Right.
Meaning that you understand through your mind, you understand in a comprehensive way, right? Anticipatorily, it means that you're applying that, what you have understood, in a way that you can anticipate future happenings, future events, how to deal with them. That lays the whole anti-entropic function. Do you guys what I'm trying to say? Right. So it goes further to talk about the political mandate. So if you understood, and then you deploy as per your understanding to encompass future maintenance, whatever that is required for those things that when they happen. And then you need appropriation. So you need your political guy,
Right,
to understand
right.
what it is. And then give the system, or give, I don't know how, I don't think that the word is, but you understand what I mean.
Yes.
Giving out the mandate that is required for them. Right? And to me, that is what you call effective anti-entropic, to align all of those things in such a way that things happen in a way that allow us to fulfill what our function in the universe is.
I just want to point out that this was a chart he gave us on design science event flow. And almost everything that John just read in that paragraph is listed here on this chart.
Mm.
With the idea of their subjective reality, this is teleology, intuition, conception, apprehension, experiment, and feedback. And over here is the generalization, the objective development, the reductive practice, and regeneration itself. And if you look down this list right here, he almost repeated that list right here.
Yeah, except for evolutionary modification. I don't know if that was in there.
Yeah.
I don't see it.
Evolutionary what?
Unless you're talking about evolutionary modification. I don't see
Yeah,
it.
but it's there.
I think this whole
It's
process,
there, but how does that fit into the?
that's his whole process right there, evolutionary modification.
Okay.
When we looked at
So
it, we
could it be
looked at-
regeneration?
yeah, it could be regeneration.
All right.
When we read this
I
list,
think it could be replacement too.
it'll be what?
Evolution. Yeah, it can be replacement
Yeah.
because
we-
you're being
You-
okay.
Yeah.
There it is, replacement.
Sorry
And
about that.
one of the things that we remarked on when we read this list was reinstallation.
Right.
Yeah.
And I mentioned an example where Kelly has a hose thing and he's replacing a hose on an engine, and the one hose mount is completely not accessible. So if he's thinking in terms of reinstallation, he might build a contraption where that hose tracks down here, but there's a way to access it from over here, if you know what I mean, because he's considering reinstallation. And thus he has his evolutionary modification.
It's interesting. If you look at this list, every one of these things has to work. Even if you were able to predict and anticipate what needed to be done, everything in here still has to work. Meaning, the manning, the operation, the logistics, the system has to work in unison. So even if I can anticipate what's required, what maintenance is required, it doesn't mean anything if my logistics is off.
Yeah.
It doesn't mean anything if my manpower is off.
Yeah.
It doesn't. So all of these things work, and this is where general systems design really kind of comes in. You have to create an ecosystem that works, where it's not just, you can't look at it as just one thing that you're taking out of this list and doing. You have to do all of them in order for it to make it work.
Mm.
Shall we continue reading? Thank you,
Before
John.
that, just a short comment is that I am doing myself a lot of comparisons between this that Bucky is telling about ships now with technology products. I
Right.
develop software like the prototyping. It's a lot of times what we do at software, and we're replacing software. We have a lot of technical debt. We need to have a lot of maintenance. There's a lot of bugs. Like, I can see a lot of useful things here. So just wanted to comment that.
And so far, he hasn't explained what prototyping 1, 2, and 3 are. I mean, he put them in there. I guess he's saying, hey, look, do a lot of prototyping. I don't know.
Exactly. Like n number of prototypes.
Yeah.
But you have today in the parlance alpha, beta version in software development. When you have it, beta is when you have some people using it. And then, Microsoft has applied that method quite nicely. In that, you have something. When they first develop an operating system, instead of having the best one, they will send it out there for people to use. And then people will feedback with the glitches, the bugs, and they correct them and they move on. Sometimes it works, sometimes it doesn't work, but that is the way of doing things.
True.
You can't develop flaw, you can't find flaws on things if you are not testing them.
The thing is that software is getting older and older. And how much time and effort are you going to spend on all software? That there might be like few people who have it working on a computer that is not worth to update it or fix it. It's just like outdated.
But you remember when Microsoft, that we're talking about, that when they moved to Windows, to real Windows.
That was 1983. Like,
What do you mean?
No, that's much later. Microsoft moved to Windows in the late 90s.
was it that late?
I didn't
Yes.
get Windows until version 3
Yeah.
because I had DOS software.
Yeah, so
way
did
more
I. Like,
effective
I had a
than-
Tandy
went
1000.
there.
I had a
Yeah.
Tandy
It was
1000.
Apple. Apple had Windows earlier.
Yeah.
Microsoft moved in a lot later.
Yeah. I was using an Ashton Tate software on DOS, and it was way more powerful than anything that Microsoft could do until they came out with Windows 3. And then you could run a spreadsheet and a word processing program on at the same time. And it wasn't until then that I made the transition.
And that Windows is complete. Is that what you call replacement, Joe? It's completely different from the DOS system that used to be
Yeah.
Microsoft standard.
Let's see if we can finish off this last
Okay.
section here. You remember where we are, John?
I do. I'm just going to find it. I think it's, I have
Under
developed.
systems. Yeah.
I have developed a
Yep.
completely workable, that's where we are, isn't it?
Yes.
I have developed a completely workable generalized systems approach, starting with the differentiation of universe, including both the metaphysical and physical, which has not only held up, but permitted progressive subdivisions in cybernetical bits to bring any local pattern of any problem into its identification within the total scheme of generalized systems events. This means that I always start all problem solving with universe and thereafter subdivide progressively to identify a special local problem within the total of problems.
Start with a macro.
Macro
Mhm.
down to micro. Yeah.
Yeah.
Cool. And that seems to be a little bit self-explanatory. Very next, we move on to a new topic.
Compared to everything else, yeah.
Yeah, which is
I
industrialization.
It's the
simplest bit today.
most clear sentence of the freaking book.
But do we get the power, I will call it, I would dare use the word powerfulness or what is just said. Cosmic hierarchy to universe. Universe, metaphysical and physical. And then that power of duality, always dividing to multiply, allows you to go finer and finer, to be able to discover and uncover, more and more complex patterns. And finer to make sense and to allow us to solve where do you have problems? A problem is always local, isn't it? There's no generalized.
I'm not sure that's always true.
Tell me where the problem is not local. Don't confuse local with you, John.
All
The
right.
problem
I'm-
is always finite. In a finite space.
But Manu, I'm in Africa and I'm relying on grain supply from Ukraine. Is it a local problem in Africa or is it a problem in Ukraine?
It's a local problem on Earth.
Ah, okay.
That's
It's
what
a
I
fair
mean.
flat universe. Okay. Okay.
Yeah. The term locality, we shouldn't fall into the temptation of limiting local to us. No.
I think
Earthian systems are still very local in relationship to universe. They are very local.
yeah, and I think it can be used both ways, John. I think local can be like local to me in Salt Lake and local to you there, but I think where Bucky's starting from macro, he always starts
Yeah.
from universe, and then he
Universe, yes.
divides down. And I think that's somehow I'm ringing a bell here where he says comprehensively and anticipatorially. In other words, a lot of people start with, oh, I have a problem in front of me, but they're not really anticipatorily looking at the problem until they look at comprehensive system.
That's absolutely true. If
Yeah.
I can, that comes back to the example that I was just telling you about. I could develop a piece of software that predicts perfectly when something's needed for maintenance. But if everything else around it doesn't work, if the system isn't coordinated, and I'm looking at it, and I'm not looking at it from from a macro perspective, then the solution's pointless. It's you're looking at it from, okay, I can tell you what's wrong with something, but I can't do anything about it. I can't get the parts that I need to the ship in time. So this is why you got to look at things from
Okay, let me just ask you guys a conundrum, right? A relative one. There is a mountain, or there is something, and there's a road that's sinuate in there, and that road has probably. How do you know the second bend of the road from where you are?
You don't.
How do you know the second bend? Not the first
If you
one.
have a map, if you have a map, that helps.
No, you run into it.
You have to go to the first bend to see the second one.
Right.
I'm talking about our process of induction.
Right.
We have to test the
that's a good
first one.
point, yeah.
So you can't have a design is not something dead, right? By method, you have to be flexible, open, always vigilant, and equanimous in considering new information. Don't be ideological and locked into something. Just always be, what if? And that's why the power is in the question.
Mm-hmm.
The power of anticipation is always in the question. What if?
And my favorite example of comprehensive and anticipatory is when I walk outside and I look at a tree. For 70 years of my life, I would look at that tree and say, well, that tree gives shade. Somebody needs to water that tree. But I've always seen the tree outside of the system of Earth. And that tree wouldn't be here without Earth. And if I realize that a tree exists in a system, I'm going to be much more comprehensive about how I look at that tree. And I'm going to be able to anticipate the needs of that tree. Because if I take that tree out of that system, it will likely die. But most white guys don't think about that. You know, Westerners are really big on taking the tree and putting it any damn where they want to, right? And they don't think about what they just did to the ecology of the space where they took the tree out. They're not thinking comprehensively. And then after a while, after so many trees die, they learn how to get a tree to survive. But is it prospering? Is that the best way to put a tree in there? Just rip it out over here and stick it over there because it's just a tree? No, it's a system, and it goes in a system. And so whenever I'm solving a problem, I want to be as comprehensive as possible about it. So I think in terms of minimums, right? Of the duality. I think in terms of, we got something here, and we got something here. Well, there's got to be something someplace else,
Mhm.
or that tree would not be alive. So what else we got going on with that tree?
How do we know that the best way to control a raging fire is to start another fire? It is counterintuitive.
Yeah.
How
Yeah.
do we know that?
Because you're getting rid
Why
of
do
it.
firefighters start another fire that is controlled
Backfires.
next to?
Yeah.
It needed for you to understand what is being burned. I see a fire. But if you didn't know that it's oxygen that is being burned, and that oxygen in that locality is finite, and
Right.
that by starting another fire, you are competing for that oxygen. So you are taking it out of a feeding of a main fire that you want to extinguish, and that will choke that fire. If you
So-
didn't understand that, you wouldn't
Or,
apply.
or even
So
then,
that's-
or even then, you're just anticipating a fire in a controlled burn, and you're getting rid of the fuel that actually could actually enable the fire itself.
Yeah.
So that this is where you have that's where controlled burns come in, is this idea of getting rid of actually the underbrush that creates the fire to begin with. But you start a fire in order to stop one.
It's back burning, when you're back burning.
Yeah,
'Cause
right.
what you want to do is if the fire is racing, you want to take away the flammable material far enough ahead of it
Exactly.
so that when it reaches that, it slows it down, stops it.
Yes, absolutely.
And you do
That
the
can
back
only be
burning.
done.
That's good forestry management.
And that you can only do it if you first comprehended what is going on. If you just stop
Exactly.
there is a fire, and the way I used to put it is put water on fire. It's going to engulf you. You won't have time to stop that fire.
And what it takes for that fire to live, you have to
Yeah.
understand that. And then that's kind of what every system, it's a systems thinking problem.
And firefighting is a very noble and very difficult.
Oh yeah, I wouldn't want to do it.
I mean, we know in the Western Cape here, like in California or in Australia, it's very fire prone. and these guys, it takes a lot. So it's not something, it is a science.
Yeah.
Oh,
There-
absolutely.
One of the solutions for homeless in California, I read, is they're taking the homeless people and training them to be firefighters. Because they like to camp, and get some gainfully employed. So anyways, all right. So Julian, how you feeling, and what are you taking away today?
Thank you, Steve. Well, I'm feeling happy, grateful that I was able to join this call today, to have these very interesting conversations with all of you. And I just realized that we were talking all of this about generalized systems, and the career that I studied is systems engineering. So that is like something that I keep finding in myself every day. And I can take away many things, many things. I think I'm going to repeat this call to watch it again later, because really good findings for education, for my software career, like to understand how do we learn. So there's all of that stuff that I take away from today. So that's a summarized way to tell you about it. I would like to hear from you, Joe. How do you feel today, and what do you take away?
Thanks, Julian. I feel very fortunate. I was able to attend a couple different events today, and I actually am going to when I get the recording from the other event, I'll send it out to everyone on this call. And I encourage you to, especially look. There's the author of this book. The Socratic Method his name's Ward Farnsworth. And he's quite an established. He runs University of Texas Law School, and he's just a really brilliant writer. And he talks about the importance of being able to ask good questions. And I thought his talk today was actually especially interesting. But I think trying to just put these things together. A lot of what we're talking about today, just everything kind of came together at one point or another, whether it would be mind and brain, topological versus topographical, how those two related, how concave versus convex with the demonstrations that Steve and Manu had given us, in closed and open systems, and I really enjoyed this last paragraph, just thinking about it in terms of looking at a real world example of how he uses the Navy as an example. And, I kind of have some exposure to that, to know what it would take to actually, all the things that it takes to actually make a system work. And to what it means to really understand a system. And I'm very, very grateful for my entire day. I'm a little tired, but I'm very grateful. That was, but I to end the day like this is, I appreciate everyone. So Manu, my friend, how are you doing? What did you take away from today?
I'm very grateful, as always, by the depth of what everybody, about the depth of what everybody gave out today. It was really exposing ourselves, and I'm truly grateful about it. I'm also happy that I'm coming out of this grown. I've learned so much. One thing that I take away is that Bucky was always very practical and very theological, in my opinion, is that he always wanted to contribute in a way that made sense in improving our conditions on this planet. And to me, it's very, very powerful. So I'm really privileged to have been among you guys and learn. So, John, how do you feel? What do you take away?
Very grateful to be here. And in fact, Manu, your last comment prompted me to think about some of the things I know about Bucky, and some of you may not know that he actually came very close to committing suicide. And when he reached that low point in his life, he didn't speak for 3 years, but he said that he was, as he was on the verge of committing suicide, God spoke to him and said that it wasn't his right to take his life. He'd been put here for a higher purpose. And he devoted the rest of his life to that higher purpose. And his research and his thinking and analysing was just quite amazing. And yes, I mean, the simplest things, the Navy is a great analogy for a complex system. And that one of the single things that is going to stick with me out of today is whenever there's a problem, go macro before you go micro. Just look for the bigger system of which the problem is a part, rather than tackling just the problem. Easy to forget when you're dealing with things on a day-to-day basis. So that alone has made it worthwhile for me. Always great to get together and exchange ideas and feel my brain being scrambled. Julian, you're not the only one who has trouble understanding. What are you laughing at, Andre? Anyway, glad to be part of this. Andre, How do you feel and what do you take out of today?
Well, I'm laughing because I'm like, man, I'm blessed I'm not the only one. I'm truly blessed to listen to all of you contributing to what Bucky's teaching and analyzing and go in depth, right? This is, I think, by far the most challenging session that I've been in. Just when I understand what the analogy or the explanation from you guys take me to a whole nother road, and I'm like, okay, wait a minute, right? And it's been great. I'm definitely gonna listen to this again to pick my brains and pick out of your brains. One thing that sticks to me today is the notion of knowledge without practice is useless and practice without knowledge is dangerous. The application of what we have learned is very, very important to practice and practice and practice and repeating that notion, because there's so much more to in depth that you can actually pick on. Especially it resonates with me today when I start to understand something and then I don't understand it at all, right? And then I understand it and then I don't, you know, and that's what life is, right? And hence why I say it's perspective, because everyone looks at one thing, but everyone has different interpretation of it as well. And the more that you understand from different angles, the more cohesive things could be. And when you have that and then you applied it, it's going to be so much more meaningful and purposeful your life could be. So that's where I'm really, I truly appreciate, you know, the conversation and the in-depth knowledge that you guys brought to the session. And Steve, so what's your take on the session today, my brother?
Okay, normally I go last, but I'm happy to go now. You called on me, so I'm happy to do that.
Are you last?
I usually am last, but Manu hasn't gone yet.
Yeah, he went.
Money went already. Yeah, I think you're last.
You're last.
I'm last.
Yeah.
Well, I'll tell you, I'm just so into it. There's a cave in my brain and I fell in. I'm blown away because I read last week, I kind of read ahead and got into the Navy thing, but I realized I've been watching SEAL Team on Paramount, CBS Paramount. I don't know if you guys have seen SEAL Team, have you? But man, that is the SEALs and how they operate. I mean, they got air and water and ground and drones and I mean, communications and ballistics and freaking, when they see an RPG or some kind of weapon over there, they know exactly how dense it is and what's going to go. In this last episode, the British guy said, we're going to take a 50 caliber and go through that bulletproof windshield, and we're going to kill that enemy combatant. And the SEAL team said, no, better off to take 30 millimeter and do 2 shots. Let the first one break the glass, let the next one kill the guy. Otherwise you'll blow the plane up. I mean, they understood ballistics that well, you know, and to have it be so second nature. And then to look at Bucky's whole process of how I make things work. And here we are doing the topology of the Navy SEAL team. I mean, it just to me, it's just so very exciting. My big thing was about this idea of mind and topology, abstract, and brain and topography. And at one point, it's kind of a versus because my brain wants to take over and I'm constantly saying, hold it, brain, stop. We're going to look at this differently. And there's a balance there because I need to live in the real world. I need to have an operating brain. I don't want to walk out in front of that truck. But at the same time, I want to live on a higher principle. I want to see some kind of purpose, design, some kind of teleology, an ontology for my life. So I thought that was cool. And we've been talking about multidimensional reality here. And I just think you guys are so courageous. I mean, Andre's saying here that, he moves into understanding, then he falls out and goes into not understanding. Then he moves back into understanding again. Well, that takes courage. That takes guts. That takes stick-to-itiveness, because there are people on this call who thought they understood, then they realized they didn't understand, and they're not here tonight because it's just too damn complicated. But I'm here to say, of course, I'm right at this right stage of my life, that this is such a meaningful conversation for me. And I'm so excited to be sharing with you guys, younger guys, older guys, medium guys with me, whatever. But I love that fact that I have to go into not understanding in order to have a better understanding. So in a way, I want to think multidimensionally, but in order to think multidimensionally, I need to think other dimension. I need to think in the other dimension that I'm not used to thinking in. So I go other dimensional, then I go multidimensional. I don't know. I'm just having a lot of fun here. And you guys are great compadres. You're great people to learn with. Okay.
It was a good time.
It was a good time. Next week, we start with industrialization. So that'll be a great thing. So, well, there's a bunch of good links in the thing. And yeah, John, go ahead.
I was just saying, I'm leaving you.
All right.
Bye all.
See you all later.
Take care.
All right. Bye-bye.
Be
Thank you,
interesting.
everyone.
Yes.
What's interesting?
It'll be interesting to see, we're reading about industrialization, but if we can somehow capture that with digital,
Yeah.
and kind of update to thinking.
Yeah, let's
Because
hope Julian's with us next week so he can
All
bring
right, yeah, cool.
his computer engineering into this industrialization conversation.
Because how there's a transition between the digital age and obviously the industrial age and
Joe, you were in the Marine, you say?
no, I wasn't.
He's a civil contractor for the Navy.
Yeah.
Civilian. He's civilian contractor for the U.S.
for
Navy,
this, yeah,
for the
civilian.
Department of
Okay.
Navy.
Yep.
Are you still doing that?
I'm still doing that.
Yeah.
still
Okay,
doing
it has to do with defense or just systems?
defense, just or acquisition.
Okay.
So
Wow.
that's why I know acquisition is screwed up.
That's really interesting.
Oh,
I
yeah,
understand that you are under kind of
it's the same thing. It's the
restraint. You cannot talk anyway. In a way
it's,
that's jeopardizing.
oh no, no, I could tell you that they're pretty inefficient. They had a goal of, they said they need a minimum of 315 ships, right? And that no matter what, they have to have this and everything. And their budgets are actually increasing. And they're like, oh, we're going to be only able to build 275 with that,
Yes.
with that money. And the reason why is because they're so inefficient. They haven't addressed the entire system. So they're very good at getting certain things done, as Steve has talked about, in the the Navy SEALs in very small groups. They're very, very efficient. But as a system, as a whole, as a group, it's highly inefficient, and they need to almost change the whole organization from the industrialized, from the Cold War mentality that they had. Organizationally, they need to adapt, and then they need some new technology that actually supports what they're trying to do.
Yeah.
But
So
it's
that kind of supports your statement about when looking at the industrialization, seeing about digitizing the industrialization.
exactly. How do you everybody goes, they still have the mentality, we need more people.
Mhm.
Well, it's the only place in the world, and I got in a little bit of trouble for saying this to one of my bosses one time. It's like, this is the only place in the world that says, boy, we really need to add money to our overhead. Like, I mean, it's like, who the hell says that out loud? That,
But
I mean,
our
it needs
government
to
is
work,
like that,
but it doesn't need people.
isn't it? Our government all over the world.
Yeah,
they
yeah,
have
it's like, oh, just give me, I just need more people. And it's like,
Yeah.
no, you need to think a little bit more. That's all. I mean, there's something that you could do other than hire somebody for the next 40 years to do something.
They're
So-
always looking for ways to increase their power, local power.
Oh, it is. Oh, that is true. That is very local, very tribal, actually.
Yeah.
Okay, my friends.
All right,
Next
take
week.
care, everyone.
Bye-bye.
Excellent.
Thank you. Bye bye.
Take care.